Now the final application we're going to consider in this module is the following one. We have three fertilizers that are each composed of potassium, nitrogen, and phosphorus according to the percents in the following table. So we have three fertilizers, as you can see, X, Y, and Z. And for fertilizer X, it's 20% potassium, 30% nitrogen, and 50% phosphorus. For fertilizer Y, it's 10% potassium, 20% nitrogen, and 70% phosphorus. And fertilizer Z, there's no potassium, and it's 30% nitrogen and 70% phosphorus. So here's what we need to find out. We'd like to know how many pounds of each fertilizer would be needed to be mixed together to get 200 pounds of a new fertilizer that's 12% potassium, 25% nitrogen, and 63% phosphorus. Now what's helpful in this problem is that the information according to what's known and unknown is organized very conveniently into this chart. So what we'll do next is define the variables maybe a little more completely and then set up the system of equations we need to solve the problem. Although X, Y, and Z were identified in the table as being the three different kinds of fertilizer, I'd like to be a little bit more specific in terms of what each of those variables actually will represent for the purpose of writing the equations in the system that we need. So I'm going to let X be the actual number of pounds then of fertilizer X, Y the number of pounds of fertilizer Y, and Z the number of pounds of fertilizer Z. Now to write the equations we need to solve the problem, we're going to look at each of the three columns in the table labeled potassium, nitrogen, and phosphorus. So let's look first at the column labeled potassium. Now we're told that the percent of potassium in fertilizer X is 20%. So if we were to take then and multiply that percent times X, which is the number of pounds of fertilizer X, then this will give us then the number of pounds of potassium in fertilizer X. And in a similar way, if we add that then to 0.10 times Y, the 0.10 times Y gives us the actual number of pounds of potassium in fertilizer Y. And to recall that there's no potassium in fertilizer Z. But we're told though that we would like the mixture to contain 12% potassium. So if we would take 0.12 then and multiply by 200, which is the number of pounds in the mixture, then we have our first equation. Now if we proceed to the nitrogen column and we follow the same format, we'll take the percent of nitrogen in fertilizer X, which is 30%, and multiply it by X. So that will give us the number of pounds of nitrogen in fertilizer X. We'll add that to then 0.20 times Y, because there's 20% nitrogen in fertilizer Y. And in fertilizer Z, there is 30% nitrogen, so it'll be 0.30 then times Z. So altogether, those added together will give us the total number of pounds of nitrogen in those three fertilizers. And we're told that we would like the mixture to contain 25% nitrogen, so 0.25 then times 200 will be our second equation. And then for the column labeled phosphorus, I think it'll be pretty straightforward. Then we can write 0.50 times X plus 0.70 times Y plus 0.70 times Z. And we're told that we would like the mixture to contain 63% phosphorus, so we'll then have 0.63 then multiplied by 200. So those are the three equations we're going to use then to solve the problem. Now what I've done next is to simplify the product on the right hand side of each equation. So for the first equation you can see that the right hand side becomes 24, in the second equation 50, and in the third equation 126. Now I think it'll be helpful if we can eliminate the decimals before we proceed further, and we can accomplish that by multiplying each equation by 10. So we'll end up then with this blue system where we have 2x plus y is equal to 240, 3x plus 2y plus 3z is equal to 500, and then 5x plus 7y plus 7z is equal to 1,260. So now we'll next work with this system to find the values of x, y, and z. Now, as the first step in solving this system, I'm going to choose to eliminate y in two different ways. And so to accomplish that, I'm going to first multiply equation 1 by negative 2, and that will produce then the negative 4x minus 2y being equal to negative 480. Equation 2 I'm going to keep the same, and if you add those two equations together, then you will get equation 4 here, which is negative x plus 3z is equal to 20. And to eliminate y in a different way now, I'm going to multiply equation 1 by negative 7, producing negative 14x minus 7y is equal to negative 1,680. I'm going to keep equation 3 the same. Then adding those two equations together, we'll end up with equation 5, which is negative 9x plus 7z is equal to negative 420. So we'll next work with equations 4 and 5 then to find the values for x and z. Now, working with the equations 4 and 5, I'm going to choose to eliminate the x terms. And to accomplish that, we're going to multiply equation 4 by negative 9, and that will produce then 9x minus 27z is equal to negative 180. Equation 5 remains unchanged, and so then if we add the two equations together, we'll end up then with negative 20z is equal to negative 600, or z then will be equal to 30. So we can next substitute that value for z back into equations 4 or 5, and we'll go from there. Now that we know that z is equal to 30, we can use equation 4 to find the value for x. So we'll do that down here then. We'll replace the z value with 30. So we have the negative x plus 90 is equal to 20. Negative x is equal to negative 70, or x is equal to then positive 70. And then to finish up, we can find y by using equation 1. So we'll substitute then 70 for x. So we'll have then 140 plus y is equal to 240, or y then is equal to 100. So as our final step now, we'll write a sentence answering the question. So our final statement then will be to write, we will need 70 pounds of fertilizer X, 100 pounds of fertilizer Y, and 30 pounds of fertilizer Z. Now in this case, I'm going to leave it to you to go through the check because I'm sure you're confident about how to do that on your own by this point.